Chapter 12, Correlational Research. Correlational research is a very popular research method that is used especially in education. And the goal is to describe the relationship between two or more variables and also see the strength of this relationship. Each correlation has three characteristics. One is the direction, that could be either positive or negative. One is the form, that could be linear or non-linear, and also the consistency or the magnitude or strength of the relationship. A positive correlation is when the two variables are moving together. In other words, as one variable increases, the other one also increases. And the negative correlation is the opposite. When one variable is increasing, the other one decreases. For example, there is a correlation between number of hours that you study and your GPA. That's a positive relationship. And an example of a negative correlation is the relationship between the number of hours you play games and your GPA. The correlation between two variables is usually shown in a graph called the scatter plot. Scatter plot shows the location of each individual on each of the two variables. So here we have a variable x and variable y, and these dots here shows the location of like participant A on the first variable and on the second variable. So this scatter plots help us to see to detect the correlation between two variables. For example, on the left hand picture we see the correlation between temperature and the amount of beer sold, and as you see, the scatter plot shows a positive trend. As the temperature goes, the number of beer sold also increases. However, on the right hand picture you see as the temperature goes up, the amount of coffee sold goes down, and the scatter plot shows this negative relationship. Sometimes there is a linear relationship, which is all the dots are on sort of a straight line, but sometimes they're not on a straight line. They go up to some extent and then they change the direction. The first situation is called linear correlation, and it's measured by Pearson formula, and the other one is called monotonic or nonlinear correlation, and it's measured by the Spearman formula. And these are examples of linear and monotonic relationship. This is another example that's a more exaggerated example that actually after a specific point the correlation changes the direction and it becomes negative. The Pearson correlation is used when both variables are numerical. In other words, if we have numerical scores for both variables. However, sometimes one of the variables is numerical and the other one is non-numerical. For example, if you want to calculate the correlation between IQ and gender, and because gender has only two categories, the correlation cannot be calculated with Pearson, so you have to use a different type of correlation. It's called point biserial. And if none of the variables is numerical, both of them have two categories, you have to use a phi coefficient. For example, if you want to calculate the correlation between gender and political affiliation, and you have only two affiliations, Democrat and Republican, then you have to use the phi coefficient to see if there is a correlation between these two variables. This is another example that you want to see the correlation between gender and success in a specific task. So you make a table, and in this table you put the number of males who succeeded in this task and the number of female who succeeded in this task, and then use the phi coefficient to see if there is a correlation between these two variables. If both variables are non-numerical and they have more than two categories, then instead of the phi coefficient we have to use chi-square. We already talked about chi-square, and for example, if you have different ethnicities and you want to see if there is a correlation between ethnicity and movie preferences, you use a chi-square to evaluate the correlation. Correlation research is used very frequently in education and has several applications. One main application is in prediction, one is for reliability and validity studies, and one is for evaluating theories. For example, you want to calculate the correlation between SAT and college GPA, and you want to be able to predict the student's success based on their SAT score. So if the correlation is high, you can predict that those who get a higher score in SAT are more likely to be successful. And for reliability and validity, we already mentioned that, for example, in reliability, we use retest to and then calculate the correlation between the pre-test and post-test to see if the test is reliable. And also for validity, we most of the time we calculate the correlation between a new test and a well-established test to see if there is a high correlation. And if there is a high correlation, we conclude that the new test is valid. If you calculate the square of a correlation coefficient, you get a value named coefficient of determination. For example, if you calculate the correlation between SAT and GPA and you get the 0.8 or 0.80, that's the correlation coefficient. However, if you square that number, you're going to get 0.64. So 0.64 is the coefficient of determination. What does it mean? It means that 64% of variability in students' GPA is associated with the variability in their SAT. So in other words, the coefficient of the determination measures the percentage of variability in one variable that is determined or predicted by its relationship with the other variable.